Brian is one of the customer success managers here as well. And when we're lucky enough to be at the office, which hasn't happened in quite some time now, I'm lucky enough to sit next to Brian. So I get to see him put presentations like this together on a pretty regular basis. I'm really excited for what Brian has to show us today with some of this reverse engineering, specifically for meshes inside of Inventor. I know that with the advancements in things like scanning technology, people have started to ask us, hey, what do we do with these files? How do we manipulate them in Inventor? So on and so forth. Brian will kind of demystify that today. If anyone has any questions, go ahead and type them into the chat panels or the questions panels, and we'll definitely get to those. But Brian, do you have anything else to add before we get started?
Nope, I'm ready to go.
All right, I will give you the imaginary microphone and go ahead and take it away.
Thank you very much. All right, let's go ahead and get on into it. Like Nigel mentioned, we have customers asking about, how can I manage my meshes or STL files inside of Inventor? What are my options? So I'm going to go over those options today when you are receiving one of these STL files and see what you can and cannot do inside of Autodesk Inventor. So first, let's briefly go over what a mesh or STL file is. It's a stereolithography. I said it correctly, thankfully. Or it's a type of file that typically a lot of 3D printers read. And it consists of these triangular polygon shaped faces, as you see here on the bunny rabbit on the right hand side, where there's points on him, 3 different points with 3 different edges, and that makes up a face. And it's essentially what we call a dumb body. I know we called step files dumb bodies as well, but STL files I would also consider dumb because it doesn't have any properties. You don't have any sketches associated with them. So I highly recommend, if you want to protect your intellectual property of your model, you can send someone an STL file and that'll do the trick. Another file type that I think is worth mentioning is the step file. I don't know if anyone knows, but it's short for Standard for the Exchange of Product Data, or STEP. Even though that doesn't even spell STEP, but that is the acronym they had for that. Is essentially a file type you'd probably would rather get over an STL file, and that's represented by the bottom red model there. And as you can see, there's there's less faces on that. They're not all triangular also, and they're just easier to work with. And for those of you in CAD, you already know what I'm talking about in that regard, because you probably received a step file in your CAD days. So, all right. So with that said, there are 2 types of STL files. There is a scanned STL file that Nigel was mentioning, where it might be more abrupt, might be more interrupted, organic looking even. There might be some holes in the scan. It's represented by the one on the left-hand side. Whereas on the right-hand side, we have something that was generated by a CAD software like Inventor, could also export as an STL. And as you can see there, these triangles are more uniform when it comes to the corners of fillets, when it comes to a flat surface, or that tapered hole, as you can see there. And this is what we're going to be working with today. And I do have a poll question for you guys. Let's see if I can go ahead and ask that. Launch polling. Which kind of file types do you work with for STLs, if any? Do you work with scan data? Do you work with the CAD exported STL files? Do you work with neither? Do you work with both? I don't think this is the correct poll, however. Sorry about that. That is not the correct poll. I'm going to go ahead and end that polling. Let me go ahead and close that. But I guess you can leave in the chat room. Sorry about that. Leave in the chat room what kind of files you typically work with, whether it's scanned or something that was CAD export. I'll give it about 20 seconds for that. And while I wait for some of these comments to come in the chat room, I see one from YouTube, CAD exported. So that's really good. So yeah, while we wait for these to come in, I want to mention that there is a tool for the one on the scan, for the scan types of STL files called Mesh Mixer that Autodesk has for free. It is an older tool. They haven't updated it in a while, but it is a tool you can use to edit your STL scan meshes, kind of like if you were to use like a Swiss Army knife on an object. So that's what Mesh Mixer is. I'll show a brief 1 minute of how that works towards the end of the presentation today. But today we'll be focusing on CAD export. And I see a couple of comments coming here in the chat. I see a lot of CAD exported data, some both, and one scanned. Gotcha. Cool. So thankfully we'll be going more of the CAD exported. But yeah, if you'd like to see more of the scan side of things, definitely leave that comment and we can have that for the next one. But today we'll be focusing more on the CAD exported one. All right. So let's go ahead and pose a scenario for today. Let's say I am in charge of building a door lock and my customer sends me this sliding bolt receiver as you see here on the left-hand side. And this is an STL file that was converted from a CAD software. And we're going to do a couple things to it. We're going to reference it into our assembly. We're going to bring it in as a component. We are going to reference it to create another 3D model from it to finish up the rest of this door lock. And then we are going to edit the sliding bolt receiver where the tapered holes are located. And as you can see, there's a lot of complex geometry going on in that mesh right now. And this is before converting it over to a solid body. So again, just a reminder there, this is not scan data, so that's going to be more complicated to work with. But this is a CAD converted data. And just a rule of thumb in general, if you're receiving a mesh, it's going to be a harder time than receiving a step file. So here are the different possible solutions you have when approaching this work. First, you definitely have to ask them if they can send you the original file or maybe a dumbed down step file of that model, because why would you need to put in more work when they can send you the actual model itself? In this scenario, we're going to say the customer says, no, I want to send you this STL file because I want to protect my intellectual property. Then you say, fine, let's move on to 2 and 3 here. Number 2, we will be referencing the mesh geometry inside Inventor to using joints and constraints and patterns and things like that to manipulate that STL file. And then number 3, we will be using what is called the mesh enabler, which I'll show you in just a moment here, which is an add-in inside of Inventor that will convert your mesh files into a solid body. And it converts primarily the CAD converted STL files efficiently, as opposed to a scan data. And that's why I brought that up earlier today. So I will go ahead and actually drag over to the screen here. I'm going to post this again halfway through the webinar here, but I'm going to go ahead and copy and paste this add-in so you guys can start taking a look at that yourself. But it's something that you guys would want to definitely try out, especially if you use these STL files. And if you already have it, then that's perfect. You don't have to bother with that. It's the same one. All right, so again, we have a chat room, so Nigel is helping me monitor that as the questions come in, and we'll go ahead and get on into it. So here inside of Inventor Professional 2021, I have my door frame assembly, and I will go ahead and import in that STL file. I'll be placing it from my downloads folder. And before I hit open, I'm going to go to options. There are different ways you can bring this in. Usually with STL files, it's going to be millimeters for the import units. By default, you probably have it under template units. And my template units are in inches. So if I brought it in via inches, you can see that this door lock is almost as big as the door. And that's not what we want. So let's go back to that file. Go back to options. And we'll change this to millimeters. Unless your template units are already in millimeters, then you can leave it as template units. Or if your STL, for whatever reason, comes in at inches, and you wanted it, or you had it set up that way, then that works as well. But just keep that in mind. The ability to change those option settings are here. So now it's much smaller, and it's something that I would expect to be of the appropriate size. Now I want to go ahead and put this mesh body onto this door frame assembly. So right now it's a mesh, and I can confirm that it's a mesh by right clicking on the model. Let's go ahead and open it up. And we can see here that it has those exact same triangular faces and things like that I described, representing the mesh. So going back to our model here. So this is not converted yet. We didn't need to use the mesh enabler or anything. This is just bringing in an STL file. So moving forward, let's go ahead and add a joint to it. So the nice thing about Inventor is that it recognizes, even though this is a mesh consisting of a bunch of different triangles, it can recognize where the center of it is, where the center of these holes are, the edges over here, maybe even the center of that. So it can recognize and smart enough to detect some of these things. So I'm going to go ahead and place it. I'm going to place it on this face, and it's going to come over, do a little animation. Instead of rigid, let's have it be on the plane. And now this guy's on the plane. So it's still a mesh STL body. Next, we can create a constraint on it as well. I can select this face here, maybe that face there. Flip it around, maybe give it a little offset. So now I have this model that is essentially part of my assembly now, and it's still an STL file. And if that's all you need it for, then you're good to go. You don't have to do anything else in addition to this. You don't have to convert it or anything. Now let's go ahead and create the second component in here, which is this part of the door locking mechanism here. And I'm going to use this as a reference, or at least try to, and I'll show you what I mean by that. So I'm going to go over here to create. I do have a numbering scheme set up automatically. And sure, I'll name it part 34. This is not as important right here. And then I'm going to select that as my starting point. Going to create a sketch on this face here. And I'm going to make you a little nauseous here. I'm going to rotate this around and hit that front of that box here. All right. So now I'm ready I want to project. I want to use this geometry to my advantage. So I'm going to go over here to project geometry. And then notice, since this is an STL file, I can highlight this edge there, which is fine, which is great. These edges here. But when I go to the outside here, it's not letting me highlight that because it doesn't recognize it completely. And also, well, I can do there, which is good. But if I try to get this line down below here, or this edge, it's giving me this circle because that's part of the STL mesh geometry. Same with some of these corners here. They're just old and things like that. And that's not what I want to reference into here. So what I can do now is I can go to the STL body. I can go to my mesh enabler. Make sure we download this. So you need to, this is free and this is online. You can search for mesh enabler. And I'm not sure if I posted that in there. Yes, I did. And I can go ahead and download this by signing into my Autodesk account. And then once you do that, you go over here to tools, you go over here to add-ins, and then it should show up right there. And if it doesn't show up right away, I would try closing Inventor and opening it back up again, restarting your computer, whatever it takes for it to show up here. And then you can make sure these buttons are, or these boxes are checked to make sure it's loaded. So once you have that loaded, that gives you the ability under your mesh feature here, when you right click, now you have the ability to convert it to a base feature or a solid body. And in this little window, you have the option to convert it to a solid or surface, and you have the option to delete the original or not. The reason it's solid or surface is because if for whatever reason this mesh was missing a face, that means it'll be it wouldn't be an enclosed body, thus it'll be a surface, which is why they have the /surface. But if it's completely enclosed, then it should create a solid for you. In this case, it's completely enclosed and it created a solid for us. If it was a surface, there are some tools inside the surface modeling environment. I'll show you some of it later today that can help repair that, or it can help find the little holes in your model. All right, so now this is a solid body. You can see that those triangles, the two triangles at the top went away. The two on here went away. Some of these still remain, but now this is something that's editable and detectable by Inventor. So for example, just a quick example here, I can create a little cut that goes through my model. Whereas before it wouldn't detect it and it couldn't cut through those meshes like I am doing there. So now that I have a solid face like that, I can go back to my assembly, and then I can project more of the face. And now with hitting E for extrude, I can go ahead and extrude this onto the door. And now we can see that this was created referencing this model here. So I didn't have to do the extra work to create this. I didn't have to go in and measure each dimension and things like that. We were able to reference the geometry of this, what was a mesh, now it's a solid body. And what I want to show also, I know it's not a mesh anymore, but I could have patterned the mesh when it was a mesh. I could have patterned it about this direction here as a mesh. I know it's a solid body now, but that's another point I'm trying to make here is you're able to not only use joints and constraints on your meshes, but you can also pattern them and things like that. All right, so that was part that's part 2 of the 3 solutions here. The last part I wanted to show, which was messing with these tapered holes here. So if the customer wanted me to create a different specific tapered hole with specific values and they don't know what this is either, then I'll go ahead and show you how I can go about editing these. So we can use what is called direct edit modeling inside of Inventor. And there's some tools, subtle tools here, direct and delete face, that allow you to do that, especially now that it's a 3D solid. So if I select this, select some of these faces here. So first off, if I try selecting from left to right, it only grabs what's completely inside the box. And if I select from right to left, it grabs everything the box touches. And you may have already known that, but I like to mention that just in case. And then I'm going to go ahead and hold Control and select the rest of these here. And make sure I don't forget these side edges. And that one right there. Now I'm going to go up here to delete face. And I will check this later, but right now I'm going to show you what it looks like if you just delete the face without healing the remaining faces. It creates a hole in there. What was a solid body is now a surface body, represented by this orange icon there. And now we need to be able to patch it up or repair this. And we could do so with some of the surfacing tools here inside Inventor. Now think of patch like you're patching up some old pair of jeans, right? So there's a hole here. I'm going to patch that up, hit apply. There's a hole down below here, same thing. It's represented by this translucent orange surface, kind of similar to the one you see here on the left-hand side. If you want to show it not translucent, you can toggle that on the left-hand side as well. Now it's not a solid body yet, it's still surface, and that's because these aren't what's called stitched together. And to do that, there is a stitching tool. So I can go ahead and select my 1, 2, and 3 surfaces to stitch together. And now it's a solid body. And the point of patching that together is so I can create my own hole tool at that location with whatever numbers that I want to put in for it. And now this is something that is smart. It's not a dumb body, or it's partially smart. With the extrusion over here, with the hole over here, with your ability to go in and edit that, edit the values there. Now we're going to do the same thing over here to this hole, but I'm going to do it without with it to repair itself when going about deleting the faces. So let me go ahead and select as many of those as I can with one click. Now I'll go back in here with Control. And let's see which ones we missed here. And that one is going to get away, but no. Now I'll go ahead and hit delete. But before I do that, I actually selected the bottom one too. So I'm going to unselect that by holding Control. Now I'll hit delete face while healing the remaining faces. So this eliminated the need to having to go in and patching and stitching things, but at least we have those tools at our disposal in case, just in case. And again, with the hole feature, we can go ahead and place that in there. And now we have holes that we can manipulate in Inventor. All right. And I also said I wanted to show the mesh mixer. It's an older tool inside of Autodesk, but it does have maybe a little bit of something for the other users, or at least one of the users that I saw that said they go into the they get scanned data, and this might be something more along the lines of scanned, because of the way it's a little bit more rough, because it's not as geometric as a lot of us are used to, like the scanned CAD data, or like the CAD exported STL files. So for example, here inside Mesh Mixer, you have the ability to use some of these tools to edit the model. They describe it as a Swiss Army knife of editing meshes. So I can just grab and pull the face of the bunny like so, and it just added more complexity to the model there. Or I can just start doing some circles there on the back just to give it some more definition, some more texture. And then this is a type of file that usually gets sent to the 3D printer. It looks like it's already assigned to get sent to a MakerBot over there at the top right-hand corner. So just to give you an idea of a software that's out there that handles this type of files. If you guys want to see more of this type of editing, let us know in the chat room for sure. Definitely would love to show something like this in the next one. But today was more focused on the Inventor and the CAD exported STL files. So to recap, we created some joints and constraints around some of the assembly or around a STL part. We were able to partially reference some of its geometry to create our own components from the STL part, and then we later converted it to a solid body to finish referencing it. And then I changed it first, but as an STL file, it could be pattern to create more instances of it as well inside of Inventor. In addition, we have the mesh enabler, which I can go ahead and post after I'm done talking here to the chat room, so you can have access to that. And it's an older tool, but you can. Oh, sorry, this is confused, or this is mixed up. The mesh mixer is for the rabbit, the tool you saw there at the end. The mesh enabler is the add-in that is used to convert it from a STL file inside of Inventor to a solid body. So I put those in the same line. Those are supposed to be separate there. And then lastly, once you convert it over to a solid body, you can have direct edit modeling tools like the ability to select those faces and then have it heal itself, or use the surfacing tools to patch and stitch itself to edit the solid bodies of the STL files. Like things like the tapered holes might be a little bit easier to modify if you're diving into some of those fillets that you saw there. That can be a little bit more complicated. And if it's just a simple part like that, like the one I went over today, maybe it's something that you'd just consider doing from scratch even. So that's, there's always an option. It's just a matter of what's the fastest way to the end result that you're trying to get. All right. So hopefully you guys took away something today that you haven't seen before. I'll go ahead and open it up for questions. And in the meantime, I'm going to go ahead and post that mesh mixer link again and the add-in again into the chat room.
Sweet. Thanks, Brian. Let's jump into some of these questions. I know there are a couple that got posted in the chat as well. So if you do have any, go ahead and type those in. Question about Mesh Enabler. What versions of Inventor have Mesh Enabler on them? I guess enabled would be the question.
Mm-hmm. I remember seeing that it was all the way back to about 2015 even.
Yeah, I think I've seen it for quite a couple of versions. So I don't remember any. And we've been doing a lot of like the what's new in Inventors for the last 5 years or so. And in the last 5 releases, it wasn't one of the things that got included. So it would be something before that. So just keep that in mind. Whatever version of Inventor you're using, it's likely in there, unless you're like in 2010 or 2012 or something. Let's see.
Let me see if I can pull that up in the meantime here.
Yep, go for it.
The one that I'm posting in the chat room is compatible from 2019 to 2021 at least. So just missing that 2018. Maybe you can search for an older iteration of it or version of it, because I remember reading about people using them in older versions.
Right. And then there's a question from someone on YouTube. Is the process the same for step files?
So for step files, essentially what you saw there at the end, it was a solid body. So it was like a step file. However, what the difference between them is, there's a bunch of different triangles, of course. So that is what I was showing today, how to go about, editing some of those. So yes and no, components that I showed today that can be used in a step file editing. And there's some like those triangles in the middle of the bird hole, which you probably wouldn't find in a step file.
Yeah, all those individual faces. So yeah, the process is similar in the sense that you're taking a non-native file and you're able to manipulate some sort of it. It's going to be different because like step file inherently is not made out of the same like triangular meshes that the STL files are, the tetrahedrals. So just keep that in mind. A little bit different. Another application that I find really useful when working with these files too, especially if you're working with like scans and stuff, is to look at something like Recap, which is also included within the product design and manufacturing collection. And so if you're looking at, wanting to play around a little bit more with some scanned data, whether they be point clouds or photogrammetry, I would take a look at Recap because 95% of the people on here don't have just Inventor; they have the whole collection. So that would be something that's included there. And there's a lot of
point. Yep.
There's a lot of tutorials and things like that on the internet for Recap specifically that you can take a look at, and it's something that's already included. So if you have like an extra hour in your day, you want to learn a little bit more about some of these workflows, it's definitely something to look into. I don't have any more questions here, Brian. Hopefully that means that you answered them all while going through your presentation.
Yeah, and just keep in mind the mesh enabler inside of Inventor. Yeah, 5,000 plus faces. It's going to start to bog down a little bit, just to give you some information when working with it. But it is really good for smaller meshes like the ones I showed today. So just keep that in mind when working
I
with
wouldn't suggest bringing in a mesh of like, I don't know, something very large. Industrial machinery, when you get to like large tanks and stuff, you're going to start to push the capabilities of application. So just keep that in mind.
Yeah, and there was a customer yesterday telling me about, there are more than 5,000 faces issue. And then when I brought it in, it came in as a surface. It still came in, but came in as a surface, which was unexpected. And then it was the matter of going into using my surface modeling tools in Inventor, and it has like a doctor kind of search where it finds where the issues are. And it was actually a little hole in the over 5,000 mesh that it was able to find. I was able to patch it, and then I was able to create a solid body out of it. So if it does have over 5,000 faces, maybe that's one of the ways you can go about making it solid again. But if it's bigger than that and there's like a bunch of different holes, that's just a fun project altogether.
For sure. Thanks for the info, Brian. I think that's everything that we have for questions today. Nice, short, and sweet AVA. So hopefully we can give you guys some of your time back this morning. And hopefully you learned something really useful. I know that going through this, the addition of like STLs into people's workflows is becoming more and more common, strictly because technology is allowing us to make our lives easier in the sense that we can scan a lot of things, but then harder in the sense that we need to be able to bring this new technology into our existing workflows. And hopefully this kind of solves some of those questions for you guys. So on and so forth. Anything else to add, Brad, before we let everybody go?
Nope. We have our emails on the screen. So if you have any other questions after this, don't hesitate to reach out.
Awesome. Thanks again, Brian. Thanks again, everybody, for joining us today. And we'll see you again next week. Thanks, everybody.
Take care, everyone.